All right, welcome to section 4.3. It's about multiplying and dividing fractions. So we're going to start to do some fraction arithmetic here. We have kind of set up our fraction stuff. So what comes next is trying to actually do some things with fractions. So we're going to try to sort of go through the classics, plus, times, minus, and divide. We'll even throw a little bit of powers and roots in there just for fun. We'll start with multiplying. The form is going to be, if I've got A over B times C over D, in general what happens is I get the numerators multiplied together over the denominators multiplied together. So you're essentially multiplying the top times the top and the bottom times the bottom. Now, that's not all there is to it, of course, right? In theory, we would like our final versions of these sort of problems to be in lowest terms. If we just multiply and multiply, we're going to get, in general, pretty big numbers, pretty good sized numbers. And, having a 50 over 75 type answer is not really what we're after. We'd much rather have that written as 2/3. So a lot of this process is not really going to be about multiplication. It's going to tie in very closely with what we were doing in 4.2, which was sort of taking our numbers apart and sort of doing a version of reducing to lowest terms. You can, of course, take, for example, 50 and 75 and reduce them to lowest terms, but it's actually going to be easier to sort of pre-reduce to a certain extent. So we're going to go through that process. In general, the one thing to watch out for, one math term that everybody seems to remember for whatever reason, is cross multiplication. Everybody always remembers sort of cross multiply, which is a concept and sort of is a technique, but it's a technique that you use when you're dealing with proportions, so not just multiplying fractions. So when you multiply again, it sort of is the top times the top and the bottom times the bottom. That's what we are working with. So to actually go through this and sort of do the reduction, I think it's going to be easiest if we just sort of do it via an example. So sort of let's start off with something like 20 over 27 times, let's say, right, 18 over 25 or something, right? So individually, none of those numbers are gigantic, right? Individually, each of these fractions is sort of already in lowest terms. So in theory, what we could do to sort of get our answer is just multiply 20 times 18 and 27 times 25, and we're going to end up with pretty good sized numbers. I don't even really know what we would get. I get 360 on top and then something on the bottom. something 75 or 50 or 25 or something hundo. That doesn't sound great. I mean, that's sort of not the best, right? You don't want to sort of get numbers up in the hundreds or thousands even potentially and then try to break them down. So let's not do that. So the technique is going to be, the concept is going to be factor first, right? So take your numbers and try to start to factor them down into smaller parts. So for example, right, 20 we could write as 4 times 5. 27 we could write as something like 3 times 9. These aren't factored all the way down, right? We're kind of going to do this in stages. 18, right, would be sort of 2 times 9. 3 times 6, 25 would be kind of like 5 times 5, right? And so just as when we were sort of reducing to lowest terms, what we were doing was sort of looking for common values in the top and the bottom and sort of dividing them away, dividing out what ended up being our GCF. We're going to look here for the same types of things. What I'm going to look for are things like, for example, 5 and 5. So on the diagonal, right, so 4 times 5, right, a 5 up here on top and another 5 over here on the bottom. those guys, if I multiplied everything out, I would get just sort of one big fraction with all of these numbers on the top and all of these other numbers on the bottom. I could sort of rearrange and cancel them out. It's not really necessary to do that. What we're going to do is just start sort of taking them apart and essentially just sort of canceling them where they are. So we can kind of cancel top to bottom, but we can also cancel sort of one for one on the diagonal. So anything from the top can cancel anything from the bottom, either under it or in the other fraction in the denominator. In this case, 5 cancels 5. Other obvious candidates, right? So just by luck, I guess, more than anything else, we have sort of 9 and 9 here. We might not have caught that sort of at first, in which case we maybe need to sort of break these things down a little bit further. So we're able to cancel 9 and 9, and so what's left over? This is sort of 4 times 2. This is 3 times 5. 4 times 2 over 3 times 5. In theory, right, we could break 4 down into 2 times 2, but that's only really going to be useful if we have a 2 sort of somewhere else here on the bottom to cancel it with. If we don't have a number to cancel it with, it's not necessary to take every single number down to its like pure prime value. So in this case, we can kind of anticipate, because we're not going to get a 2 down here, and 4 is only going to give us 2's up top. We're kind of good to go as far as reducing it. So our last step here, once we've canceled out the pieces that we have in common, is just doing the multiplication. 4 times 2 is 8 in my numerator, and then 3 times 5 is 15 in the denominator. And that's going to be my final answer. I actually end up here, even though I'm multiplying with kind of individual numbers that are smaller than all of the numbers that I started with, right? 8 and 15 are smaller than all of my other digits. That's not uncommon, even though we're multiplying. Again, the idea is we're sort of reducing down and canceling out all this common stuff. Let's look at another example. Let's sort of do an example with some new numbers. How about 24 over, I don't know, 35 times 49 over maybe something like 36. Same kind of idea. I'll actually go maybe one step further. Let's call this maybe a negative 24 times 35. I can throw a little parentheses around here if we've got a negative number, right? It's not totally necessary, but you know, we could do that. One of the things here that will happen, right, is if I have a negative times a positive, my answer will be negative. That's not really going to affect any of the work as we go. We'll just kind of keep track of that negative, and we can essentially just sort of move right into trying to sort of break these numbers down. What would this be? Well, 24 would maybe be like 4 times 6. 35 is like 5 times 7. 49. Some of these we don't really have a lot of options. 36. What could we call that? 3 times 12 or something. Right. So maybe we do that. In theory, right, this negative is still sort of out here in front. It's not really sort of having a big impact on these individual pieces, but it's something. What have we got? Well, so for example, 7 will cancel 7. My other digits, I don't necessarily have any obvious things to cancel. I can sort of fish around and see what else I can do, because 4 and 6 will both break down a little further. 12 will also break down a little further. And so what I'm going to do is, let's say 12 instead of 12. 12 would be maybe 2 times 6. So I'm going to sort of go fishing for the biggest possible values I can. So 6 and 6 will cancel. That would leave me with, let me sort of write this out. So this is, right, a negative. This is going to be, 4 times 7 over 5 times 3 times 2. If we start to get a little cluttered, we can sort of rewrite what we've got and then keep looking. So 5 and 3 and 2, those guys are all primes. Maybe the last thing here to do would be 4, which would be 2 times 2. In which case, right, this 2 on the bottom will sort of cancel out. One of those 2's from the top. That's going to leave me with the negative of 2 times 7 over 5 times 3. So my final here is going to be negative 14 over 15. And that's the basics of it. I mean, one of the things here to sort of watch for is as you're going through this, if you end up with what you think is a final answer, but it's actually not in lowest terms, that's not really a big deal. Like, you can always just keep reducing. The idea with this kind of like pre-breakdown and sort of pre-cancellation is you're trying to get rid of any sort of values early, and you're trying to save yourself from doing any kind of like extra multiplication that you don't really sort of want or need. Let's do one more of these, and I'm going to actually mix in a couple variables here. Let's do negative sort of 15x squared over 16 times, I'll throw some parentheses around this. Let's do a double negative. How about 28 y squared over, I don't know, 45 x cubed. So maybe I have something kind of like this. If I start to mix variables in, just as when we were sort of reducing by lowest terms, we can kind of expand our variables out, and then just again, sort of just like with the factors, cancel them kind of one for one. We'll also sort of notice in this case, right, this is sort of a negative times a negative should be a positive. So we can maybe even just sort of do that as a sort of a step number one. Negative times negative is a positive, and then we don't even really need to worry too much about these positive or negative signs as we go. Let's break everything down here, right? So 15 would be 3 times 5. X squared would be sort of x times x. 16, let's call this maybe 4 times 4. 2 times 8, right? I mean, lots of different ways to sort of write this. 2 times 2 times 2 times 2. You can go all the way, even right from the start. 28 would be like 4 times 7, y squared, y times y. 45, 5 times 9 maybe would be the kind of obvious way to go, and then 3 of these x's. So just like we did before, let's cancel everything we can. So numbers, 5 and 5, 4 and 4. And then any variables, in this case, we could do sort of, again, kind of one for one, x and x. So we're left with 3 and 7 and y and y. We're left with 4 and 9 and x. Everything right, negative times negative is positive. So this is 3 times 7 times y over 4 times 9. 4 and 9 will break down a little bit further. In particular, 9 would be 3 times 3, right? So one of these 3's I can cancel out. 4 would be 2 times 2, but we're also just working here with a 7. So I feel pretty good leaving this as 7y squared over 4 times 3. So that's going to be 7y to the 2 over 12. Negative times negative is positive, so our final answer here is going to be positive 7y squared over 12. And that's the basics for multiplying, right? So it's actually a lot of factoring and a lot of division. The multiplication is kind of the very, 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 very last step of this problem. In some sense, after everything has been really far reduced. So rather than usual multiplication where we kind of intuitively expect to get bigger and bigger numbers, you're not necessarily going to get that here. Sometimes you will, but in a lot of these problems, especially sort of in the book problems, which are designed to break down, you're actually going to end up, in some sense, with smaller numbers than you started with.